So, hello everybody, my name is Carlo Zanchetta, and here with me there is Jacopo Cassandro. Together with Maria Grazia Donatello, Claudio Mirarchi and Alberto Pavan, we are involved in a project in which a public authority commissioned a study to develop a price list and cost references to be implemented in public procurement bin-based, okay? So today we are sharing this first part of the research, which is dedicated to the analysis of the reliability of IFC classes in ontology definition and cost estimation of public procurement. So it's just the first part of the study. Okay, so as I mentioned, the public authority asked for the definition of cost references to be developed and implemented in bin-based public procurement. The main problem is that there is no structured cost domain available, and this is a problem because clearly structured data is essential for the digital platform to be developed for the public procurement. On the second hand, this generates a huge problem because as we will see later, it's not possible to validate the cost data when they are directly implemented in BIM models. So the data is typically closely related to the information contained in BIM models. So this generated the first approach to the whole project because as you can see, if you pay a look to the typical practices and literature, the cost information and the cost specification is typically linked to the BIM models throughout some extra attributes, okay? So this generates the definition of costs inside some models that are not part of the cost domain who is in charge to the public procurement. Okay, so to solve this problem, we started analyzing a different approach, and to be honest, the approach was found analyzing the data model, the IFC data model, in which it is not defined as a procedure to enrich directly the models by editing some attributes, but to define a whole new cost domain made of cost items. And the cost items, as you can see, permit to create information classes, cost information classes, which are enriched with multiple attributes, and that can help create multiple and different kind of relations between the cost items based on the cost domain and the geometric domain, which is based on the BIM models. So this helped us to represent to the authority the possibility to define completely a cost domain and the strategies to link the costs to the items. So now Jacopo will illustrate how we managed this experimentation.
Yeah. This is the two research questions that come from this problem statement, and to support and verify and improve the quality of cost estimates in public tendering, the study proposed both the identification of a structure for cost database on IFC and the reliability and application of these methods. And this will make it possible to identify a standardized procedure for storing, exchanging, and linking the cost information to the model objects. And to this end, an approach was adapted to consider the cost element as a structure class in IFC data model, known as IfcCostItem, and this entity contains a set of attributes in which information can be instantiated and cost ontology based on structure classes can be identified. As visible in the slide, the entity of IfcCostItem can relate with different information, such as price information, quantity information, but also with product and also resource, such as material resources, equipment resources, and labor resources. Currently, cost data is not structured, and this causes misunderstanding, inaccuracy, and errors in the selection and association of these price items to their respective geometric object. A structure with defined and standardized fields is necessary for the breakdown of the current cost items, and this will allow to place the information into specific field or attributes by structuring data, ensure the validation and consistency between the attributes of certain cost classes and the attributes of the geometric object which it is associated, and also to consider the cost items no longer only as a text strings but as replicable entities. The research aims to identify a cost ontology and the standardized supporting procedure to verify that the costs are in line with the model objects, and for this is necessary to relate the digital model to the cost element described through the structure class in the IFC, and the correctly return and the analysis and the processes of economic evaluation. It is necessary to have an architecture of cost items and that are configured as more complex systems than a simple attributes associated with the geometric object. Due to the heuristic approach of this paper, the research focused on analyzing an example case of a wall. This wall consists of 6 layers, and the respective items containing the price list have been identified. After that, the items were broken down into the standardized structure, and the relative cost items, IfcCostItem, were identified. This entity is an entity that represents the cost of an asset, of a service, the execution of a work by a process, life cycle cost estimates, and so on. And not all cost information can be added into these attributes of this class. And how can we see? And the remaining one that express, for example, the information of the physical objects such as construction method, thermal conductivity, the size parameters, and the function, and so on, cannot be contained directly into this entity, and is necessary to activate the relationship with other entity into the IFC data model. The goal is to create a price list that characterized by these entities, where each price list items will be an independent cost classes and can be associated with the relative model object. At the operational level, considering the design standard, the whole package was divided into 3 different parts, 2 architectural and the structural part, and the price of the 3 parts will be given by the unit price of the price list multiplied by the quantity of the model object. Every unitary IFC cost item contains specific information and data based on the original description given by the price list, and the IFC standard also through cost classes offers the possibility of structuring this cost data, creating a cost architecture and not a simple identifying an attribute to associate to the BIM object. The developed method was implemented using the currently official version of IFC4 and IFC OpenShell, an open source library for Python. And the validation of the code is made through one of the most known validator, FZK Viewer, but as confirmed by the developers, some data nowadays have not yet been implemented in the validator, and therefore is necessary to validate the result inside the text viewer. This first example is the slide relative to the validation of the unit cost and unitary cost item, and the second is relative to the association of the cost to the object. In conclusion, this study is still in the first phase of development, presented how the cost items can be structured through IFC entity, and the results show the scalability, and the method can be implemented for other cost items, and also ensure the accuracy between the geometric entity and the cost architecture, creating this relationship between these 2 entities. There also, however, it's possible to obtain this result only through code, because there are no currently a user-friendly tool for implementing the cost architecture. And also the future works will be concentrated in the application of the methodology to a more complex case study, and to structure this class an analysis of, as an analysis and in the logic of price analysis, and to ensure the correctness and uniqueness of the association through verification system. We try to verify, the verification will be executed on parameters hard-coded in the data model IFC and therefore already presented in the standard. And if the object attributes are not the same with the cost, the test result will be positive. Then if the geometric object attributes are different, the platform will inform you about this difference and this discrepancy, and will suggest you to use a different and possible alternative of cost items. Thank you.
Thank you.